Okay guys, welcome back. Now that we just got what's the intuition behind the varying or random slope for our capstone projects for the Alzheimer, and we saw that what do we mean based on the previous tutorial that we had. It means that we look at the cases that the rate of the change of the brain atrophy between the groups, between the levels of the group of demented and non-demented is going to be different. And now that's the time that we just put that into the action and just do that with STAN program. All the thing that we have, just do not to do the data as a list. We still use the data stand for model B. However, the only thing that we have to change is gonna be the code that we wrote that in, I should say, for the model B AD stand. In order to do that, I'm just gonna go ahead, open a new file, and just open a text file. And for the text file that I have, I'm just gonna save it as, I have to make sure that save it as a stand file. I'm just gonna call that model. Now I'm just gonna call that model C. And also I'm just gonna call that AD, which it signifies that this is for the Alzheimer's disease. And now I just make sure that I end the name of the file with the stand.stand and save it the way as a stand file. You can see the change of the symbol of the, I should say, the new tab, you have it over there. And now, in order to continue with the coding, we do not need to just start writing every individual piece by piece. I'm just going to go back to the previous model that we just wrote in the stand. I'm just going to copy paste it there because lots of the blocks that we created there, it's just going to remain the same. There should be some minor changes, and now I'm just going to just implement the minor changes on each block that we created before. Also, I'm just going to save it as the way which I just pasted the stuff in there. Okay. I'm just going to start with the data block, and let's see if there should be any changes there. Because I'm just working with the same group, my data is not going to be changed. I have still the number of the observation the same, my response variable, and also my predictor variable remains the same. I have still the same number of the levels within the group, and also I have the same indexing method for any observation, which I'm just going to tag them and give them an ID to make sure that which observation belongs to which, I should say, levels in that group, either converted, demented, or non-demented. Then as a result, the data block remains completely intact and no changes needs to be done. Okay. I'm just going to go to the parameters, but there is one tiny minor change which I need to do at the parameters, the block. And the thing which I'm just going to do, still I'm just going to keep, I should say, the sigma as a real number there. However, I defined the U as a distribution of all the random intercepts and the changing intercepts. I assume that all the changing intercepts within different levels in the group, they are just going to make a kind of a distribution. And I just call that, I should say, I put all those different changing intercepts inside the vector. But it was a one-dimensional vector. Now imagine in that case, as I'm just going to show that to you inside that on this cartoon, which I on the notes which I have drawn here. As you will see now, I do not have only the intercepts changing. I extended the model from here to there, and besides from the intercepts which they are changing, I also have the slope that is changing, and that's the purpose for this tutorial, that the rate of the brain atrophy between different levels of the group, if they are going to be converted, demented, or non-demented, they are going to be different. And then as a result, I do not have these lines parallel compared to the one which I had on the previous model. Then as a result, I have two things this is changing. One is going to be the intercepts, then also it's going to be the slope. Then I have, because it's going to be a two-dimension vector, it's going to be much easier for me that instead of the vector, I show that as a kind of matrix. Then I'm just going to only change the vectors with the matrix. However, I know that matrix I have, it has two rows. One of them is going to be, I should say, for the changing intercepts, and the other one is going to be for the changing slope, and each column is going to represent the level of the group that I'm just considering. It can be converted, demented, or non-demented. And also I have to just make a little bit difference, that for the changing intercepts and slopes. Okay. Then as a result, the standard deviation of the measurements which we have for both the changing slope and the intercepts, in this case, it's going to become a vector. Then it's changing to a vector, and also I know that if the vector, because it refers to standard deviation, and it has to be, I should say, a positive number, but I know that it also each vector in the stand should be denoted by its length. I should say, and if you guess the length of that vector is going to be g, the number of the levels within the group, which is going to be 3, because the standard deviation we have is going to be measured between different levels within the group. Then as a result, the vector has a length of 3, denoting the standard deviation for each level inside the group. And also, I have the same thing here for the mu. I just keep it the same. I make sure that at the end of each block, I just save data that I have. I just go to the next one. However, there is a little bit change also for this part. And the change which we have to just make into transform parameters, I have to say it becomes the most important one as we have it over here. By doing this, I'm just going to create, essentially I'm just going to write a model for that, because as you know, we are just going to write a linear model. By doing that, I'm just going to add another loop inside the for loop which I had, and I'm just going to say that for. I'm just going to, because probably I have j values, I'm just going to start from here and start with the k. I say k, which is going to be from this range within this series of 1 going all the way to the j. It's not going to be n anymore. And also, in order to show the intercepts, I'm just going to show that 1, u is going to be a matrix, 1 is going to show, I should say, the changing slope, the changing intercept, and I have also, it's going to be the group, which I'm just going to say that it's going to be from the group K. The K is going to be the level of the group which I have, and also I have to add it into the varying slope. How is the varying slope is going to be? It's a kind of a linear line. The varying slope is going to take that format. It's going to be essentially like, I'm just going to go with the U. I know that the second row represents the varying slope. I'm just going to have the comma, and I have the group, and I have, again, the index is going to be the K. And that's going to be all the thing about, I should say, my varying slope. I know that my varying slope is multiplied to the h as a predictor value, which the h comes with the I, because we have I represents all the observation, and I is just essentially the index for the age, refers to the age of all the participants in our study. I don't forget to just put the semicolon there, and essentially by writing something like that, it means that we are done with the transforms parameters block as the way which it is. Remember, any level of the hierarchy, as you're going to see that on the next tutorials, that when we include, I should say, the stage of the Alzheimer in as another level, an additional level into our analysis, we have to add one more for loop in there. But also we have to make sure that we have the curly brackets closed for everyone, and that's fine. We have the curly brackets for each one. However, we have this one for this one for that. We do not have for the 4. I forgot to just put the curly brackets for the second 4, and I'm just going to add another curly brackets, which it means that for the second for loops, I close it with another curly brackets. I'm going to save it. Yeah, it seems that I have everything. Okay. Now, the other thing which I'm just going to do, I'm just going to do another change which is inevitable. It's going to be, I should say, for the priors and and the likelihood. For the likelihood that we have there, we do not just make any other differences, because based on the thing that we had for the normalized whole brain volume bar, we get it from here, and also sigma remains the same. But also we just need to incorporate some changes for, I should say, for the priors. The changes that we're just going to have for the priors, then we have the U1, which represents the distribution for the changing intercepts. Then it becomes sigma U1. Remember, 1 denotes here, I should say, the distribution that we assign for the changing intercepts. And U2 is going to be the distribution that we assign for the changing slope, which again, it's going to be a normal of the center distribution and also the sigma U, however, just specifically for the changing slope. Then as a result, you will see that we can just, when we define the sigma U, we can just specify that for the same thing. If we just have some information about the data, then I have sigma U. I have 2 here, which denotes, I should say, my information about the same thing. I can just write that as, again, as a Cauchy. I'm just going to have it centered and 1. And also, we can have the same story as you have here, as you can see that for, let's say, for the sigma, I should say, as you will see for the sigma itself. And now let me see what is the error message that we have. Okay, and now we can just take that as a flat priors in order to just get rid of that the error message that we have. We have, I should say, the sigma 2 and also sigma 1. In order that you have any problems with the priors, you can always remove that in order to have a flat priors that the data speaks for itself. And also when we just come back, I should say again, to the generated quantities, we can keep everything as the way it is, and there is not going to be any need for any changes for this one. And also that's essentially, that's all that we need. The data block is done. The parameters block has been successfully written. The transport parameter is completely done. And also, as you can see, the model quantities block is done. And now, as we have saved it, then what do we have to need to do is that go back, I should say, to the R and just execute the code and interpret the results that we have got. We are just going to do that when we just come back from for the next tutorials. At this tutorial, we're essentially done by defining, I should say, the stand file. With the next tutorial, we're just going to execute the file and see that if the rate of the brain atrophy within different levels of the group, if they are demented, non-demented, or converted, is going to be different. Then see you at the next tutorial.